Welcome to Math Contest Drills for Filipino Kids. In this presentation, let us continue answering the 2016 Elimination Round for Grade 10 students. This is part 2 of 2 parts, numbers 26 to 50. Let us repeat the instruction. Give all fractions in lowest terms and all equations of lines in the form ax plus by equals c, where a, b, and c are relatively prime integers. A is greater than 0. Number 26. Suppose an object is dropped from the roof of a very tall building. After t seconds, its height from the ground is given by h is equal to negative 16t squared plus 625, where h is measured in feet. How long does it take to reach ground level? For our suggested solution, we are given the function h is equal to negative 16t squared plus 625. For the object to reach ground level, h must be equal to 0. Then we have 0 is equal to negative 16t squared plus 625. Adding 16t squared to both sides of the equation, we have 16t squared equals 625. This time, let us get the square root of both sides of this resulting equation. So we'll get 4t is equal to 25. Now let us divide both sides of the equation by 4. We get 25 over 4 seconds. Or this is equal to 6.25 seconds. Number 27. In triangle ABC, AB is parallel to DE. AC equals 10 centimeters. CD equals 7 centimeters. And CE equals 9 centimeters. Find the length of segment BC. For our suggested solution, let us illustrate triangle ABC as described in the problem. So we have triangle ABC. Then we have segment DE that is parallel to segment AB. The endpoints of this must be on side AC and side BC of the triangle. Since DE is parallel to AB, then we have two similar triangles in here. Triangle CDE, similar to triangle CAB. We are given that AC is equal to 10 centimeters. Also, CD is 7 centimeters. And CE is 9 centimeters. From the similar triangles, we can form a proportion about the corresponding sides of the two similar triangles. That is AC over the corresponding side to triangle CDE, that is CD, equal to the corresponding sides BC and CE of the two triangles. Substituting the given values, AC is equal to 10, CD is equal to 7, and CE is equal to 9. From here, we can get the value of BC multiplying both sides of this equation by 9. Then we can get BC is equal to 9 times 10, that is 90 over 7 centimeters. Number 28. Find the polynomial p of x of degree 3 that has zeros negative 2, 0, and 7, and the coefficient of x squared is 10. Here is our suggested solution. If the zeros of the polynomial are negative 2, 0, and 7, then we have x equals negative 2, x equals 0, and x equals 7. From here, we have the factors of the polynomial such that x plus 2 equals 0, also x equals 0, and x minus 7 equals 0. If these are the factors of the polynomial of degree 3, then we can form a polynomial equation x plus 2 times x minus 7 equals 0. Multiplying these factors, we have x squared plus 2x times x minus 7 equals 0. Then we have x squared times x is x cubed. X squared times negative 7 is negative 7x squared. 2x times x is positive 2x squared. And then 2x times negative 7 is negative 14x equals 0. We have x cubed minus 5x squared minus 14x equals 0. If the coefficient of x squared is 10, we can multiply both sides of this equation by negative 2. Then we have a polynomial equation, negative 2x cubed plus 10x squared plus 28x equals 0. Hence, the polynomial or the polynomial required is p of x is equal to negative 2x cubed plus 10x squared plus 28x. Number 29. Find the equation in the form ax plus by equals c of the perpendicular bisector of the line segment joining 1, 4 and 7, negative 2. Here is our suggested solution. The perpendicular bisector of the line segment must pass through the midpoint of the line segment. Hence, first let us get the midpoint or the coordinates of the midpoint of the line segment joining 1, 4 and 7, negative 2. That will be 1 plus 7 over 2 for the x coordinate, 4 plus negative 2 over 2 for the y coordinate. Then the midpoint has coordinates 4, 1. Also, the perpendicular bisector and the line segment or the line containing the line segment are perpendicular, so their slopes must be the negative reciprocal of each other. Let us find the slope of the line containing the line segment. That will be negative 2 minus 4 over 7 minus 1, that is negative 6 over 6, and this is negative 1. Then the slope of the line or of the perpendicular bisector is the negative reciprocal of negative 1, that is 1. To find the equation of this perpendicular bisector, we're going to use the slope or the point slope form. Y minus y sub 1 is equal to the slope times x minus x sub 1. Then we have y minus 1 equals x minus 4. Negative x plus y equals negative 4 plus 1. This is negative 3. The first term of the line must be positive. So we have x minus y equals 3. Number 30. The sides of a polygon are 3, 4, 5, 6, and 7 centimeters. Find the perimeter of a similar polygon if the side corresponding to 5 centimeters is 9 centimeters long. For our suggested solution, If two polygons are similar, then the ratio between corresponding sides is equal to the ratio between their perimeters. Let A be the 5 centimeter side of the first polygon and B be the corresponding side, which is 9 centimeters. Also, let P sub A be the perimeter of the first polygon. Let's call it polygon 1. Then this is equal to 3 plus 4 plus 5 plus 6 plus 7. And this is equal to 25. 3 plus 7 is 10, 4 plus 6 is 10, and then plus 5, 25. Also, let P sub B be the perimeter of the next polygon or the similar polygon. Let's call it polygon 2. So as I have mentioned, if two polygons are similar, the ratio between their corresponding sides, A to B, is equal to the ratio between their perimeters. P of A is to P of B, P sub B. Let us substitute the values. A equals 5, B equals 9. Perimeter of polygon 1 is 25, and we're looking for the perimeter of polygon 2. By cross-product property of proportion, the product of the means equals the product of the extremes. So from this, we can form an equation solving for the perimeter of the second polygon, P sub B. This is equal to 9 times 25 divided by 5. 25 over 5 is 5, so we have 9 times 5, 45 centimeters. Number 31. If tangent theta equals 2/3 and theta is in quadrant 3, find cosine theta. For our solution, we'll use the concept of circular functions. If theta is in quadrant 3, then we have the rectangular coordinate system, the x-axis and the y-axis. The radius vector is in quadrant 3, and we're going to form the right triangle with the x-axis. So we have theta. Then we know that tangent theta is equal to y over x. Y is the y-coordinate of the endpoint of the radius vector, and x is the x-coordinate of the endpoint of the radius vector. And the right triangle formed will have 2 as the length of the opposite side of theta, and 3 as the length of the adjacent side to theta. So let r be the length of the radius vector. R therefore will be equal to the square root of x squared plus y squared. So r is equal to the square root of 13. 4 plus 9 is 13. Also, we know that cosine theta is equal to the adjacent side to theta, which is x, over the radius vector. Since the end of the radius vector is in quadrant 3, then the coordinates of the endpoint must be -3, -2. So the x-coordinate is -3, then we have -3 over the square root of 13. Rationalizing the denominator, we have -3 is square root of 13 over 13. That is cosine theta. Number 32. The first term of a geometric sequence is 1536, and the common ratio is 1/2. which term of the sequence is 6. For our suggested solution, we're going to use the formula for the nth term of a geometric sequence, where a sub n is equal to a sub 1 times r raised to n minus 1. A sub n is the nth term, a sub 1 is the first term, r is the common ratio, and n is the number of terms. So from the given problem, a sub n is what we are looking for, the value of n, and this is equal to 6. A sub 1 is 1536. The common ratio is 1/2. Hence, we do not know the value for n. Substituting the values, we have 6 is equal to 1536 times 1/2 raised to n minus 1. Dividing both sides of this equation by 1536, we get 6 over 1536 equal to 1/2 raised to n minus 1. Simplifying 6 over 1536 by dividing both numerator and denominator by 6, we get 1 over 1536 divided by 6 is 256. And we know that 256 is 2 to the 8th power. So 1 over 256 is 1/2 raised to the 8th power. And this is equal to 1/2 raised to n minus 1. At this point, let us use the one-to-one property of exponential functions, where we have the same basis. Then for these two values to be equal, the exponents must also be equal. 8 is equal to n minus 1. Adding 1 to both sides of the equation, we get n is equal to 9. Therefore, 6 is the 9th term. Number 33. In triangle ABC, the measure of angle B equals twice the measure of angle A. The bisectors of these angles meet at point D, while BD extended meet AC at E. If the measure of angle CEB equals 70 degrees, find the measure of angle BAC. For our suggested solution, let us illustrate triangle ABC as described in the problem. So we have triangle ABC, although this drawing is drawn not to scale. We have the bisectors of angle B and angle A, which meet at point D, and BD extended meets AC at point E. We are given that angle CEB measures 70 degrees. Now, let measure of angle A be equal to 2x. So when angle A is bisected, each of the congruent angles formed by the angle bisector measures x degrees. Also, measure of angle B is equal to twice the measure of angle A, then this is equal to 4x. Then each of the congruent angles formed by the bisector of angle B measures 2x. Now focus your attention on triangle ABE. If we have triangle ABE, then angle BEC is an exterior angle, or angle CEB is an exterior angle of triangle ABE, where angle A and angle ABE are the remote interior angles. Now, by exterior angle theorem, the measure of the exterior angle, that's measure of angle CEB, is equal to the sum of the measure of its two remote interior angles. Measure of angle A plus measure of angle ABE. Substituting the values, we have 70 is equal to 2x plus 2x. Then 70 is equal to 4x. Solving for x, we divide both sides by 4. X is equal to 35 over 2. And since the measure of angle A, this is also the measure of angle BAC is equal to 2x, then the measure of angle A or angle BAC will be 2 times 35 over 2. And this is equal to 35 degrees. Number 34. Find the sum of the series 1/3 plus 2 over 3 squared plus 2 squared over 3 cubed plus 2 cubed over 3 to the 4th power plus, and the pattern continues. For our suggested solution, let us evaluate each of the exponential expression in the fractions of the terms in the series. So we have 1/3 plus 2 over 9 plus 4 over 27 plus 8 over 81 plus, and the pattern continues. Let us check whether this is a geometric series. That is to check whether there is a common ratio. R is equal to the second term divided by the first term. This must be equal to 4 over 27, the third term, divided by the second term. Dividing fractions, we copy the dividend and multiply this by the reciprocal of the divisor. So we have 4 over 27 times 9 over 2. Simplifying, we have 3 over 9, that is 1/3. So this is equal to 2/3. On the other side, 4 over 2 is 2, and 9 over 27 is 1/3. Then this is equal to 2/3. The common ratio, there is a common ratio which is 2/3. And notice that the common ratio is between 0 and 1. That is a proper fraction. Therefore, the series is an infinite geometric series. And the formula for the sum of an infinite geometric series is a sub 1 over 1 minus r. Let us substitute the values. That will be 1/3 over 1 minus the common ratio, 2/3, and this is 1/3 over 1/3. Therefore, the sum of this series is equal to 1. Number 35. What is the remainder when x cubed minus x plus 1 is divided by 2x minus 1? For our suggested solution, let us use the synthetic division. In synthetic division, we copy the coefficients of the term in the polynomial, that is the dividend, in descending order of the degrees in term. So we have 1 for x cubed, 0, since we do not have a term with x squared as the variable, negative 1, and then 1. For the divisor, we have 2x minus 1 equals 0. Let us get the value of x. 2x equals 1, so x is equal to 1/2. Bringing down the coefficient of the first term, then multiply 1 times 1/2 is equal to 1/2. Then add 0 plus 1/2. Multiply this sum again by the divisor, 1/2, that is 1/4. Negative 1 plus 1/4 is negative 3/4. And then negative 3/4 times 1/2, that is negative 3 over 8. 1 plus negative 3 over 8 is 5/8. In synthetic division, where the divisor is linear, the last sum is for the remainder. Hence, the remainder when x cubed minus x plus 1 is divided by 2x minus 1. The remainder is 5/8. Number 36. Triangle ABC has right angle at B. If measure of angle C is 30 degrees and BC is equal to 12 centimeters, find the length of the side AB. For our suggested solution, let us illustrate the right triangle described in the problem. So we have angle B as the right angle. Angle C is 30 degrees. Then we can say that angle A is 60 degrees. Since the acute angle or the acute angles in a right triangle are complementary. Of course, this drawing is not to scale. We have a 30, 60, 90 degree triangle theorem which states that the side opposite 30 degrees is half as long as the hypotenuse. So if the side opposite 30 degrees is x, the hypotenuse is 2 times x of length. The theorem also states that the side opposite 60 degrees is square root of 3 times as long as the side opposite 30 degrees. So if the side opposite 30 degrees is x, the side opposite 60 degrees is x times square root of 3. From the given, we have BC is equal to 12, and from the theorem, BC is equal to x square root of 3 if AB is of length x centimeters. So we're going to equate the values for BC, that is from the theorem, x square root of 3, and the given BC is equal to 12. Dividing both sides of this equation by square root of 3, and then rationalizing the denominator, that is to multiply both numerator and denominator by square root of 3, will get 12 square root of 3 over 3. Therefore, x is equal to 12 over 3 is 4, so we have 4 square root of 3 centimeters. Number 37. What is the largest root of the equation 2x cubed plus x squared minus 13x plus 6 equals 0? For our suggested solution, we're just going to find all the rational roots of the given equation and identify which of these roots is the largest. From rational root theorem, since the constant term is 6, and its factors are 1, 2, 3, and 6. The coefficient of the leading term is 2 and its factors are 1 and 2. Then we have the possible roots or possible rational roots of the polynomial equation as positive negative 1, positive negative 2, that is from 1 over 1, 2 over 1, also 3 over 1, and 6 over 1. So we also have positive negative 3 and positive negative 6. Also we have 1 over 2, 2 over 2, 3 over 2, and 6 over 2. That is positive negative 1 half. 2 over 2 is also 1. Positive negative 3 halves, and 6 over 2 is also 3. Now, to find which of these possible rational roots are actual roots of the given equation, we will use synthetic division. So we have 2, the coefficients of the terms in the polynomial equation, 1, negative 13, and 6. Let us begin with positive 1. We bring down the coefficient of the leading term, so we have 2 times 1 is 2 plus 1, that will be 3. And then 3 times 1 is 3 plus negative 13 is negative 10. And then negative 10 times 1 is negative 10 plus 6, negative 4. The last sum is not 0, so 1 is not a rational root. Let us have negative 1. Again, bring down 2. Then 2 times negative 1 is negative 2 plus 1. That's negative 1. And negative 1 times negative 1 is positive 1. Plus negative 13, that's negative 12. Negative 12 times negative 1 is positive 12 plus 6, that is 18. Negative 1 is not a root also. So we proceed to 2. Then we bring down 2. 2 times 2 is 4 plus 1. That is 5. 5 times 2 is 10 plus negative 13. That's negative 3. And then negative 3 times 2 is negative 6 plus 6, 0. Therefore, 2 is one of the roots of the given equation. Then we have this reduced quadratic equation, 2x cubed plus 5x minus 3 equals 0. Let us try to get the discriminant of this quadratic equation to know whether it still has rational roots. That's b squared minus 4 times a, that is the coefficient of the leading term, times negative 3. So we have 25 plus 24. This is 49, a perfect square. Hence, 2x cubed plus 5x minus 3 has rational roots. Let's do that by factoring. 2x is 2x. 2x squared is 2x times x. This must be 2x squared. And then 3 is 3 times 1. So we have 3 times 1. The second term is positive. The bigger product must be positive. That's 2x times 3. And the smaller product must be negative, so that the last term is negative and the middle term is positive 5. From these two factors of the quadratic equation, we can get the other two roots. X is 1/2, also x is negative 3. Hence, of the three, 2 is the largest root of the given equation. Number 38. Find the equation in the form x squared plus y squared plus cx plus dy equals e of the circle that has points 1, 8 and 5, negative 6 as the endpoints of its diameter. For our suggested solution, we will first get the equation of the circle in center radius form, and then from that, we can convert it to the required form. So, the center radius form of the equation of the circle is x minus h squared plus y minus k squared equals r squared. To find this equation, we need to get the coordinates of the center hk and the length of the radius r. Since the circle has its endpoints of the diameter given, then the center must be the midpoint of this diameter. So the center will be at the midpoint of 1, 8 and 5, negative 6, or the segment joining 1, 8 and 5, negative 6. So we have 1 plus 5 over 2 and 8 plus negative 6 over 2. Therefore, the center is at the point 3, 1. We can get the value of r by substituting h equals 3 and k equals 1 from the center to the center radius form of the equation of the circle, or simply, we're using the distance formula. So r squared is equal to, let us use either of the endpoints of the diameter. Let us use 1, 8. So we have 1 minus 3 squared plus 8 minus 1 squared. Therefore, r squared is equal to 4 plus 8 minus 1 is 7. 7 squared is 49. This is 53. So the equation of the circle in center radius form, substituting the value of r squared and the coordinates of the center, we have x minus 3 squared plus y minus 1 squared equals 53. Translating this to the required form is to expand the binomials in the left-hand side. We have x squared minus 6x plus 9. Y minus 1 squared is y squared minus 2y plus 1. We have equals 53. Arranging the terms of this equation, we have x squared plus y squared minus 6x minus 2y equals, and then we subtract 10 from both sides of the equation because 9 plus 1 is 10. So we have 53 minus 10 in the right hand side, 43. So the equation of the circle is x squared plus y squared minus 6x minus 2y equals 43. 39. The distance from the midpoint of a chord 10 cm long to the midpoint of its minor arc is 3 centimeters. What is the radius of the circle? Here is our suggested solution. Let us illustrate the circle described in the problem. So we have a chord that is 10 centimeters long. The minor arc, we have the distance from the chord to the midpoint of the minor arc. That means the arc is bisected into two congruent arcs. And that distance is 3 centimeters. Also, the chord must be divided into two equal parts. Then one part is 5 centimeters. If from the center to the midpoint of the bisected arc is the radius, then we have this segment from the chord to the center of the circle as r minus 3. If we let r be equal to the radius. Then from the center to the end of the chord, or to one end of the chord, is also the radius of the circle. Let this be equal to r. Now we have formed a right triangle with the hypotenuse as r, the legs as 5, and r minus 3. From the Pythagorean theorem, we can have the equation r squared is equal to 5 squared plus r minus 3 squared. So from here, we can get the value of r. R squared is equal to 25 plus r squared minus 6r plus 9. R squared minus r squared is 0. Then we subtract, or we add 6r to both sides of the equation. We'll have 6r is equal to 25 plus 9 is 34. So r is equal to 34 over 6, or 17 over 3 centimeters. Number 40. Find the equation in the form ax plus by equals c of the tangent line to the circle x squared plus y squared equals 25 at the point 3, negative 4. For our suggested solution, let us illustrate the circle and the tangent line described in the problem. Let us have the rectangular coordinate system with the x-axis and the y-axis. If the circle has the equation x squared plus y squared equals 25, this must be a circle with center at the origin and the radius equal to 5 units. A tangent line touches the point at the coordinates 3, negative 4. And we're looking for the equation of this tangent line. We know that at the point of tangency, the radius from center of the circle to the point 3, negative 4 is perpendicular to the tangent line. So if we can know if we know the slope of the radius, or the line containing the radius, we can have the slope of the tangent line. If two lines are perpendicular, their slopes are the negative reciprocal of each other. At the origin is the point 0, 0, so we can have the slope of the radius or the line containing the radius, that is negative 4 minus 0 over 3 minus 0. And this is equal to negative 4/3. Hence, the slope of the tangent line is the negative reciprocal of this slope, that is 3/4. So we can find the equation of the tangent line using the slope and a point. Substituting these values to the point slope form of the equation of the line, we have y minus negative 4 equals the slope times x minus 3. What I'm going to do is to multiply both sides by 4 so that y plus 4 will be multiplied by 4, and then distribute 3 to the parentheses in the right hand side of the equation. So we have 4y plus 16 equals 3x minus 9. Arranging this equation to the form ax plus by equals c, or the standard form, we have negative 3x plus 4y equals negative 25. Then let us multiply both sides of the equation by negative 1 so that the first term is positive. 3x minus 4y equals 25. That's the equation of the tangent line. Number 41. How many triangles can be formed by 8 points, no 3 of which are collinear? For our suggested solution, we're going to use the idea or concept of combination. From 8 points as the choices, we can choose any 3 of these points as long as no 3 of these 8 points are collinear to form a triangle. The formula for combination is combination n taken r is equal to n factorial over n minus r factorial r factorial. From the given information, n is equal to 8 and r is equal to 3. So we're solving for combination 8 taken 3. So we have 8 factorial over 8 minus 3, that is 5 factorial times 3 factorial. 8 factorial is 8 times 7 times 6 times 5 factorial. We stop at 5 factorial because we have a 5 factorial in the denominator. 3 factorial is 3 times 2 times 1. 5 factorial over 5 factorial is equal to 1. And 6 over 3 times 2 is also equal to 1. Then 8 combination 3 is equal to 56. Therefore, there are 56 triangles that can be formed with 8 points, no 3 of which are collinear. Number 42. Two tangents to a circle form an angle of 80 degrees. How many degrees is the larger intercepted arc? Illustrating the figure described by the problem, we have a circle and two tangents intersecting in the exterior of the circle. These two tangents, according to the problem, forms an 80-degree angle. The circle is divided into two arcs, one is smaller and the other larger. Let x be the measure of the larger intercepted arc, and then the smaller intercepted arc must be 360 minus x. From this information, we can have the equation 80 is equal to 1/2 the difference between the larger intercepted arc and the smaller intercepted arc. Multiplying both sides by 2, we have 160 is equal to x minus 360 minus negative x, that will be plus x. So we have 160 plus 360, adding 360 to both sides of the equation. Then x plus x is equal to 2x. Then 2x is equal to 520. Dividing both sides by 2, we have 260 degrees. Number 43. Find all real solutions of the equation x raised to 1/2 plus x raised to 1/6 minus 2 equals 0. For our suggested solution, we let m be equal to x raised to 1 over 6. Therefore, m cubed is equal to x raised to 1 over 6 raised to the third power, or this is equal to x raised to 3 over 6, that's 1/2. Substituting these values, we can rewrite the equation as m cubed plus m minus 2 equals 0. We now have a polynomial equation where the coefficient of the leading term is 1 and the constant term is negative 2. Then all the possible roots of this polynomial equation, according to the rational root theorem, the possible rational roots are positive negative 1 and positive negative 2. Let us use synthetic division. So we have 1, 0, we do not have m squared, 1, negative 2. Let us begin with positive 1. So we bring down 1. 1 times 1 is 1 plus 0, that is 1. 1 times 1 is 1 plus 1, that is 2. Then 2 times 1 is 2 plus negative 2, that is 0. Hence, 1 is a root of m cubed plus m minus 2 equals 0. We now have a reduced quadratic equation in m squared plus m plus 2. The coefficients are 1, 1, and 2 equals 0. Before we proceed, let us try to identify whether this equation still has rational roots. Let us find the discriminant. So we have b squared minus 4 times a times c. A is 1, the coefficient of the leading term. B is 1, the coefficient of the second term. And c is 2, the constant term. This is equal to negative 7. A discriminant that is less than 0, that means the roots of this quadratic equation are complex conjugates. And these are not rational roots. Therefore, there is only one rational root to the equation, and that is m is equal to 1. Now, if m is equal to 1 over 6, we can get the value of x. X raised to 1 over 6 is equal to 1. Then, x is equal to 1. (44) The sides of a triangle are 6, 8, and 10 centimeters respectively. What is the length of its shortest altitude? Here is our suggested solution. Let us illustrate the right triangle described in the figure, and let us name its vertices as A, B, and C. Since this is a right triangle, because the lengths of the sides are 6, 8, and 10, this forms a Pythagorean triple. 10 squared is equal to 6 squared plus 8 squared. The longest side, the hypotenuse, is 10. The shorter side, BC, is 6. And the longer side, AB, is 8. Since this is a right triangle, we have side CB and side AB as altitudes also. So we can draw the shortest altitude from vertex B to the hypotenuse AC. Let us name the point on AC as point E. From here, we have three triangles that are similar. That is from the similarities in right triangles. So we have triangle ABC similar to triangle AEB. Notice that EB is the shortest altitude, as what is required in the problem. So from this similarity, we can have the relationship AB over AE is equal to BC over EB. Also, AC is equal to, or AC over AB. Again, from the similarities in two right triangles, we have the relationship AB over AE equals BC over EB equals AC over AB. Then we will use the relationship BC over EB equals AC over EB to find the value of EB. We have 6 over EB is equal to 10 over 8. Cross multiplying, we have 8 times 6, 48. And EB times 10, so that is 10 EB. Therefore, EB is equal to 4.8 centimeters. That is the length of the shortest altitude. Number 45. In a circle of radius 10 centimeters, arc AB measures 120 degrees. Find the distance from B to the diameter through A. For our suggested solution, let us illustrate the circle described in the problem. So we have arc AB formed by two radii. Let us have point A and point B on the circle. This arc measures 120 degrees. From the central angle theorem, the central angle formed by the two radii is also equal to 120 degrees. Now we're looking for the distance from point B to the diameter through A. So let us draw the diameter through A, and we're looking for that distance, perpendicular distance from that diameter to point B. If the radius of the circle is 10 centimeters, then from the center of the circle to point B, that is the distance 10 centimeters. Notice that we have a central angle that is 120 degrees. This is forming a linear pair with that angle of the right triangle formed by the diameter and the perpendicular distance from B to the diameter. Hence, that angle measures 60 degrees. And since this is a right triangle, the acute angle at B in this right triangle is 30 degrees. So we have a special right triangle following again the 30, 60, 90 degree triangle theorem. If the hypotenuse is 10 centimeters, then the length of the side opposite 30 degrees is half this measure, that is 5 centimeters. And the side opposite 60 degrees, that is the distance from B to the diameter, is square root of 3 times as long as the length of the side opposite 30 degrees. Then this is 5 square root of 3. Number 46. Find the remainder when x raised to 100 is divided by x squared minus x. For our suggested solution, let us use the synthetic division with a quadratic divisor. Writing the coefficients of the polynomial x raised to 100, we have 1, 0, 0, 0 until we have 100 zeros. So we have 1 and 100 of these zeros. For the divisor, we get the opposite sign of the coefficients in the second term and the constant term in the quadratic divisor. The coefficient of the second term is -1, so we have +1. And then we have no constant term, therefore we'll use 0. Then let's proceed to synthetic division, bringing down the coefficient of the leading term. We multiply this by the first divisor, that is 1 times 1, we have 1. Then add, this will be 1. The sum is to be multiplied again by the first divisor, 1 times 1, that is 1. And then the previous sum or the previous coefficient is to be multiplied by the second divisor. 1 times 0 is 0. Then we add 0 plus 1 plus 0 is 1. And then the sum will be multiplied by the first divisor again. 1 times 1, that's 1. And then the previous, that is also 1, multiplied by the second divisor, that is 0. Then this will be 1. Notice that this process will continue until the last or second to the last coefficient of the dividend. So we'll have 1, 0, and then 1. Again, 1, 0, and then 1. But in this case, we will not multiply this sum by the first divisor. We'll just multiply the previous sum because this is the second to the last term. We'll multiply the previous sum by the second divisor, that is 1 times 0, 0. Then the sum, the last sum will be 0. We know that dividing polynomials with quadratic divisor, the last two sums are for the remainder. Since it's not both, or since they are not both 0, there is a remainder to this polynomial division. That is x plus 0. Therefore, the remainder, when x raised to 100 is divided by x squared minus x, the remainder is x. Number 47. Find the area in terms of pi of the circle inscribed in the triangle enclosed by the line 3x plus 4y equals 24 and the coordinate axis. Our suggested solution, let us illustrate the triangle and the inscribed circle described in the problem. Let's have the coordinate axis. We have the y coordinate or y-axis and the x-axis. Then the line 3x plus 4y equals 24. Notice that if x is equal to 0, y is equal to 6. And if y is equal to 0, x is equal to 8. Then the x-intercept of this line is 8, 0, while the y-intercept of this line is 0, 6. If we plot those points and connect, then we will have that line formed by 3x plus 4y equals 24. Let us name the intercepts. We have 8, 0, and 0, 6. This time, let us draw the circle inscribed in the triangle formed by the coordinate axis and the line 3x plus 4y equals 24. Since the y-intercept is 0, 6, the length of the shorter side of the right triangle formed is 6. The length of the longer side of the right triangle formed is 8. That is the distance from the origin to the point 8, 0. Since this is a right triangle, the length of the hypotenuse of this right triangle will be 6 squared plus 8 squared, that is 100, square root of that, 10. Then this is the right triangle 6, 8, 10. Now, let x be the radius of the inscribed circle. So we have from the center, perpendicular to the x-axis, that will be the radius. Also, that is equal to from the center, perpendicular to the y-axis, that will also be x. So if this length is x, from the y-intercept of the line to the point of tangency, this is 6 minus x. By two tangents theorem, from 0, 6 to the other point of tangency, this is also of length 6 minus x. And since the hypotenuse is of length 10, then this will be from the point of tangency to the x-intercept of the line. This will be of length 10 minus 6 minus x. And this is equal to 4 plus x. Again, from two tangents theorem, the length from the x-intercept of the line to the point of tangency on the x-axis, this is also of length 4 plus x. And since the longer side of the right triangle is of length 8, from the point of tangency to the y-axis, this will be 8 minus 4 plus x, and that is 4 minus x. Then we have an equation. Since x and 4 minus x are equal by two tangents theorem, we can equate x is equal to 4 minus x, then 2x is equal to 4, then x is equal to 2. If x, or the radius, is 2 units, then the area of the inscribed circle is 2 squared pi, and that is 4 pi square units. Number 48. In how many ways can 5 persons be seated in an automobile, having places for 2 in the front seat and 3 in the back, if only 2 of them can drive and one of the others insists on riding beside the driver? For our suggested solution, let us illustrate the situation. We have 2 choices for the front seat, including the driver's seat, and then we have 3 choices in the back seat. Since there are only 2 of these 5 people that can drive, then we have 2 choices in the driver's seat, that is 2 times 1. And since one of them, or one of the others, insists on riding beside the driver, we only have 1 choice in that position. Then the remaining 3 will be 3 times 2 times 1. So the number of ways can be simplified as 2 factorial times 3 factorial times 1. 2 factorial is 2 and 3 factorial is 6 times 1. So there are 12 ways to do this situation. 49. Factor completely the expression x raised to the 4th power plus 3x squared plus 4. Our solution is by adding and subtracting suitable terms. From the given x raised to the 4th power plus 3x squared plus 4, if we add x squared and then subtract this again, minus x squared, then we would not be changing the value of the expression. But notice that we have formed a perfect square trinomial in x to the fourth plus 4x squared plus 4. Then we have minus x squared. Factoring this perfect square trinomial, we have x squared plus 2 squared minus x squared. Notice that we formed another special product, that is the difference of two squares. Then we factor this as x squared plus 2 minus the square root of the second term times x squared plus 2 plus the square root of the second term, that is x. Rewriting these two factors, we have x squared plus x plus 2 times x squared minus x plus 2. Number 50. A bag is filled with red and blue balls. Before drawing a ball, there is 1/4 chance of drawing a blue ball. After drawing out a ball, there is now a 1/5 chance of drawing a blue ball. How many red balls are originally in the bag? For our suggested solution, let R be the number of red balls originally in the bag, and B be the number of blue balls originally in the bag. From the first situation, without drawing or before drawing a ball, the probability of drawing a blue ball is 1/4. Then we have the number of blue balls over the total number of balls in the bag, that's B plus R. This is equal to 1/4. Cross multiplying, we have 4B is equal to B plus R. Then 3B is equal to R. Let's have this as equation 1. In another situation, when a ball has been drawn out, the chance of drawing a blue ball has reduced to 1/5. So that is B minus 1, because a blue ball has been drawn, over B plus R minus 1 is equal to 1/5. Cross multiplying, we have B minus 5 is equal to, or 5B minus 5 is equal to B plus R minus 1. Simplifying this equation, we have 4B minus R is equal to 4. Let us have this equation 2. Substituting R equals 3B to equation 2, we have 4B minus 3B is equal to 4. Then B is equal to 4. This is the number of blue balls. Then the number of red balls will be 3 times B, which is 4. Then we have 12 red balls in the bag originally.